Hi, welcome back to ChemTube channel. I'm Jaegu Wong. Today we are going to look at the Terengganu TOV paper 2, section B, the essay question, and the section C also. So before we start, okay, please like this video and then share with your friends first. Okay, thank you. So we look at question number 9. Okay. Diagram shows the part of the periodic table of elements. The letters do not represent the actual symbol of the element. So you are given W, X, Y, Q, R. Okay, it's given these elements in this periodic table. Okay, so for this type of questions, when you answer your questions, when you write your answer, you just use the letters given here, no need to use the actual one. Okay, first question. State the meaning of the group in the periodic table. So you have to define the meaning of the group correctly. So what is group? It is the vertical column of elements in periodic table. Okay, then how are we going to arrange them in the group? Okay, according to the number of valence electrons of atoms. So it depends to how many valence electrons it has. So for example, Q and R, it has one valence electron, so they are put in the group 1. Okay, X, Y, they have 7 valence electrons, so they are put in the group 17. Yeah. So next question, Q and R, they are located in a group 1 in the periodic table. So state another name of the group 1. So another name for group 1 will be alkali metal. So 2 marks. Next, write the electron arrangement for the atom X. State the position of the X in the periodic table. So we look into where is the atom X? So atom X is located at here. So we can look into here. Okay, X, it is located at group 17. Okay, 17 meaning that it has 7 valence electrons. Okay, then it is located at period 3. Okay, so period 3, so meaning that it has 3 shells occupied with electrons. So meaning that the electron arrangement will be 2A3. Okay, so this is the electron arrangement. So where is the position of the X in the periodic table? So it is located at group 17, period 3. Okay, so this is your answer. Now, table 9.2 shows the physical properties of elements X and Y. So let's see, X and Y, they are in group 17. Okay, so X in the gas form, Y in the liquid form. Okay, so we can look into the melting point and the boiling point, okay, for element X and Y. So compare the melting and boiling points of the element X and Y. Explain your answer for 4 marks. So meaning that you have to write 4 points. Okay, so first we look into the melting and boiling point. So which one has a higher melting and boiling point? Okay, I think you should be able to see it, right? So element Y, it has a higher melting and boiling point compared to element X. So this one becomes your first point. Okay, so point number 1, element Y has higher melting and boiling point. then X, element X. Okay, so point number 2, okay, Y, because we look into Y, Y, it has more electron shells, so it has more bigger molecular size, right? Okay, so molecular size of Y is bigger than X. So what is the consequences? So if the molecular size is bigger, so meaning that the attraction force is stronger. So what is the attraction force for the molecules? So you can specify it. So the van der Waals force of attraction of element Y is stronger, okay, stronger than X, okay, stronger than X. Okay, so if the force of attraction is stronger, so what is the result? So more heat energy is required to overcome the stronger attraction force. Okay, so it has a higher melting and boiling point than the element X. So 4 marks. Okay, if you have any question, you can ask in the comments below. Okay, now we look into table 9.1 shows observation for experiment to study the reactivity of group 1 elements when we react with water. So element Q, okay, let's see, it moves faster, okay, quite reactive now, and randomly on the water surface with hissing sound, ignites with a yellow flame. Okay, you ignite means burns. Okay, now element R, let's see whether it is more reactive or not. So it moves vigorously, yes, so meaning that it is more reactive compared to element Q. Okay, then ignite with a lilac flame and produce a pop sound. Okay, then the solution, both solutions, it turns the red lemon pepper to blue. This one also the same. So meaning that we know this one will be the alkaline. Okay, now state the properties of the solution form. Okay, so just now I mentioned to you already, so it is alkaline. Okay, so 1 mark. So write the chemical equation for the reaction between the Q and water. So okay, so Q react with water, H2O, so it produces the QOH and QOH with the hydrogen gas, So we have to balance the equation. So 2, 2, 2. Okay. Okay. So after we write the chemical equation, right? Okay. Calculate the volume of hydrogen gas when 2.3 grams of Q reacted with the water at the room condition. Okay. So let's see this one. Yeah, given 2.3 gram of Q, meaning that given to you this metal Q, then the question asks you to find the volume of hydrogen gas. Okay, so volume of hydrogen gas is this one. So we have to do the calculation for this. So first we can calculate the number of mole first, number of mole. Okay, given to you is 2.3 grams, so it's 2.3 over the molar mass for the Q is 23, so over 23, so you will get 0.1 mole. Okay, so this is the first thing you need to find. Okay, so after that you need to find the volume, right? But before that you need to do the mole ratio between the Q and the hydrogen gas. So you need to do the mole ratio. Okay, so from equation, 2 mole of Q, so produce 1 mole of hydrogen gas, right? Okay, so next from calculation you will get 0.1 mole only. So if 0.1 mole for the reaction, so meaning that 2 to 1 meaning that is 0.05 mole of hydrogen gas. So meaning that in this reaction the mole for the hydrogen only 0.05. Okay, so after you get the number of mole for the hydrogen, so next you can find the volume of hydrogen gas. So you will get 0.05 times molar volume at room condition is 24. So you will get is 1.2 cubic decimeter. So unit must be stated correctly to get the full score. Okay, next question. Compare the reactivity of elements Q and R. Explain your answer. So 4 marks. Let's see, Q and R. Q and R is the group 1. So meaning that Q and R here, when going down the group 1, the reactivity is increased. In other words, R is more reactive compared to Q. Okay, so 4 marks, we have to have 4 points. Okay, so let's do the explanation here too. So you can mention element R is more reactive than element Q. Okay. And after that, why it is more reactive? So you have to mention atomic size of R is bigger than Q. Okay, so if atomic size is bigger, what is the consequences? So the valence electrons, it has 1 valence electron, right? Is further from nucleus. Okay, so if valence electrons is further from nucleus, okay, then the attraction force is weaker, okay, because the distance is further, right? Okay, for element R, okay, compared to Q. Okay, then it is easier, okay, to release 1 valence electrons, okay, to achieve stable octet electron arrangement, okay, for element R compared to Q. Okay, next question. Diagram 2 shows the one use of the element W in the weather balloon. Okay, state the name of the element W. So in your opinion, what is the rationale of use the gas W in weather balloon? So 2 marks. Okay, so the elements W, okay, so this the gas W is helium gas. Okay, why helium gas is used So helium gas is light, non-flammable, and stable. Okay, so it has achieved stable duplet electron arrangement. Okay, so it does not react with other elements. Okay, so in actual fact, you can also find out hydrogen gas actually can be used also, okay, in the weather balloon if you search online. Okay, but we will suggest you to use the helium gas because it is non-flammable. Hydrogen gas is flammable. Okay, next question. What is mean by strong acid? And then name one example of the strong acid. So first you have to define the strong acid. So acid is a substance or chemicals that ionize completely in water to produce high concentration of hydrogen ions. Okay, so the keywords here must be ionized completely in water. And then another one is to produce high concentration of hydrogen ions. Okay, so it is fixed. Is weak acid. If weak acid, it will be ionized partially in water, produce low concentration of hydrogen ions. Okay, now name one example. So you must give the name. So actually in the SPM level, remember, okay, so hydrochloric acid, okay, nitric acid also accepted, or sulfuric acid. Okay, now next, explain why the glacial ethanoic acid does not change the color of the blue lemon pepper to red. Okay, so you just need to remember, if you see the word glacial means it is dry, or pure means no water inside. No water inside. So here glacial ethanoic acid, okay, glacial ethanoic acid contains molecules only. So it does not ionize. Okay, so there is no hydrogen ion present. Okay, so it does not change the color of blue lemon pepper to red. Okay, very simple. Now excess magnesium powder is added to 50 cubic centimeter of 1 mole per cubic decimeter nitric acid solution to form the salt Z. Name the salt Z and then write the chemical equation involved, then calculate the mass of the salt Z form. Okay, so here magnesium powder. Okay, so we can write the equation first. So magnesium powder react with nitric acid. Okay, so acid with metal, it will produce a salt, right? So the salt will be magnesium nitrate and the hydrogen gas. So we need to balance the chemical equation. So this one is, you need 2 times 2 here. So it is balanced. So 2 marks, 2 marks here. Now, I name the salt Z. So the salt Z is magnesium nitrate. Okay, magnesium nitrate. Okay, now calculate the salt Z, a mass of the salt Z. So meaning that you have to find the mass of the salt Z form. Okay, given to you. Okay, magnesium is excess. Excess. Magnesium is excess. So meaning that this one is excess. So we do not look into it now. So this one is the limited one. So we can find the number of mole. So first, number of mole of nitric acid first. So you are given MV, right? Okay, volume concentration. Okay, so MV over 1000. So M is 1.0, V is 50 over 1000. Okay, so you will get 0.025 mole. Okay, so this is the first step you can do. Now step 2, we can do the mole ratio. Okay, mole ratio, you can see here 2 mole of nitric acid. Okay, produce, this one is 1 mole, right? 1 mole of magnesium nitrate. Okay, so if from the calculation 0.025 mole of nitric acid, so you will produce 2 to 1 means half, right? So you will get half of it, meaning that sorry, just now this one I calculate wrongly here. This one should be 0.05. Okay, here is 0.05 mole. Okay, so if here 0.05, so here this one is 0. More. Okay, means half, meaning that this one will be half of it, 0.025 mole of magnesium nitrate. Okay, so here you have known already, this is 0.025 mole of the salt produced. So we can find the mass of the salt, right? So magnesium nitrate. You have the mole, 0.025 times the molar mass is given to you is 148 times 148. So you will get is 3.7 gram. Okay. Okay, next table shows the information of action of heat on 2 types of salts, P and Q. So here, salt P, you heat it, okay, deliver the gas into the lime water. Let's see. The residue R here, okay, is a yellow solid when hot, white solid when cold. So this one you have to know under salt chapter. So this one is a zinc oxide, it's fixed. Then lime water turns cloudy, meaning that it has a carbon dioxide release. So in other words, the salt P, you have to know it is a zinc carbonate. Okay. Next, if salt Q, you heat it, okay, you bring a burning, is it, or glowing wooden splinter. Okay, let's see. Residual, yellow solid when hot, white solid when cold. So this one also the same, same with the previous one, will be zinc oxide. Brown gas will be nitrogen dioxide. And then the gas C rekindles the glowing splinter, so it will be oxygen. So meaning that the salt Q will be zinc nitrate. Okay. So let's see the questions. Okay, based on the table, identify the residue R, gas A, gas B, and gas C. So here, I mentioned to you already, residue R with zinc oxide. Okay. Residual R will be zinc oxide. Gas A will be carbon dioxide, no? Gas B will be nitrogen dioxide. Gas C will be oxygen. So 4 marks already. So another 10 marks, another 6 marks. Write the formula of the salt P and salt Q. Okay, so salt P and salt Q already given. So this is salt Q, this is salt P, the formula. Okay, now describe the chemical test to identify the anions in the salt Q. So salt Q is nitrate, okay, nitrate ions. So how are we going to test the nitrate ions? Okay, so it is the brown ring test. Brown ring test. For testing of the nitrate ions, okay, first we put in 2 cubic centimeter of dilute sulfuric acid is added into the test tubes containing the nitrate ions, followed by 2 cubic centimeter of iron 2 sulfate solution. So the test tube is then shaken. So after that, the test tube is slanted and held with a test tube holder. So after that, a few drops of concentrated sulfuric acid are dropped along the wall of the test tube, and it is held upright. So meaning that in this testing, right, you need to add in 3 chemicals. First one is the dilute sulfuric acid, followed by iron 2 sulfate, then finally concentrated sulfuric acid. So after that, what is observed? So you will see the brown ring is formed. So brown ring is formed, confirms the nitrate ion is present. Okay. Okay, for section C, starting from KSSM this year, so there is only one question in this section C, so no choice. So all the students must learn how to answer the questions correctly. So a student carry out 3 sets of experiments to investigate the factor that affects the rate of reaction. So time taken to collect 50 cubic centimeter of hydrogen gas is recorded in table 11. So the time taken to collect 50 cubic centimeter. So set 1 is used 100 seconds. Set 2, 50 seconds. Set 3, 25 seconds. So the highest rate of reaction will be set 3, followed by set 2, then finally set 1. So let's see what is the reactants used. So set 1, okay, sulfuric acid with zinc carbonate granules. So here we look into the concentration of the sulfuric acid and zinc granules. Okay, so set 2 we see same concentration, okay, but using the powder, okay, powder, zinc carbonate powder, meaning that this one will be smaller size, bigger total surface area. Okay, then set 3, same concentration, zinc powder, okay, but here the temperature is higher, temperature is higher compared to set 2. Okay, so that's why it has a highest rate of reaction. Okay, next, based on the experiment, give a meaning of rate of reaction. Okay, describe meaning of rate of reaction. Describe how to test the gas produced. So test the gas produced. So gas produced here will be the hydrogen, is the carbon dioxide gas. Write the balanced chemical equation. Then calculate the maximum volume of the gas X produced in the set 1. Set 1. So 7 marks. So first we need to define the rate of reaction, right? Okay, so based on the rate of reaction, we can define it as the time taken to collect 50 cubic centimeter of the gas X in the experiment. Okay, so you can define the the rate of reaction. Okay, so it's the time taken to collect 50 cubic centimeter of gas X, okay, in the experiment. So it's the rate of reaction. Okay, now how to test the gas? Okay, later on we write the balanced chemical equation this. Okay, so sulfuric acid with zinc carbonate. Okay, sulfuric acid react with zinc carbonate. Okay, so it will produce a zinc sulfate is a salt, water, and carbon dioxide. So this one is a balanced chemical equation. So the gas X here actually is the carbon dioxide gas. Okay, so how to test the gas? Okay, so for the carbon dioxide gas, right? Okay, test for the carbon dioxide gas. So bubble the gas X into test tubes containing lime water. Okay, so you will observe the lime water turns cloudy. Okay, so confirm the carbon dioxide gas is present. Okay, so after that we need to calculate the volume of gas produced. Okay, here, okay, we can do the calculation for the number of mole. Okay, so here you see zinc carbonate is excess, so meaning that sulfuric acid is the limited reagent. So we will calculate the number of mole for the sulfuric acid. Okay, then compare with the volume of gas. Okay, so next we need to calculate number of mole of sulfuric acid. Okay, we use the MV over 1000. Okay, so M is 0.2, concentration 25, volume is 25, not 50, over 1000. You will get 0.005 mole. Okay, then after that we need to do the mole ratio. Okay, so 1 mole of sulfuric acid so produce 1 mole of carbon dioxide. Okay, so meaning that if 0.005 mole of sulfuric acid, so it will produce the same mole, 0.005 mole of carbon dioxide. Okay, so meaning that volume of carbon dioxide gas, so it will be mole 0.005 times the molar volume is 24, so you will get 0.12 cubic decimeter. If you want to change to cubic centimeter, it will be 120 cubic centimeter. Okay, next, based on the table 11, then compare the rate of reaction. Okay, so set 1 and 2, just now actually we compare already. Set 1 and 2, set 2 has a higher rate of reaction compared to set 1. Okay, so set 2 has higher rate of reaction than set 1. Okay, set 2 and set 3, so set 3 has higher rate of reaction than set 2. Okay, so by referring to collision theory, explain your answer in the first one, set 1 or set 2, or you want to compare set 2 and set 3. Okay, so you can choose any one of these to answer your questions. Okay, so let's say we look into both. Okay, set 1 and set 2. It is because of the total surface area. Then set 2 and set 3 is because of the temperature. Okay, so we look into explanation using the collision theory one by one. Set 1 and set 2, or you can choose set 2 and set 3 to answer this question. Okay. Okay, for the first one, B1, if you want to compare the set 1 and set 2, so it will be factor of size or total surface area. So what are the points you need to write? So first, you need to mention in set 2, zinc carbonate powder, so it is in the powder form. So powder has a smaller size, okay? So it has a bigger total surface area exposed for collisions. So after that, the frequency of collisions between, okay, here you have to mention the particles correctly. Zinc carbonate and the hydrogen ions from the acid is higher in the set 2. So if you write particles here, so you cannot get the points for this point number 2. Cannot get any marks. So you have to mention the particles correctly, specify it. So after that, the frequency of effective collisions is higher in set 2. So it has a higher rate of reaction. Meanwhile, if you want to mention about the B2, okay, B2 actually is the factor of temperature. So in set 3, the temperature is higher than set 2, which is 40 degrees Celsius. So this increases the kinetic energy of reacting particles, and the particles will move faster. So the frequency of collision between, again, the particles you have to mention correctly, zinc carbonate and the hydrogen ions is higher in set 3. So after that, you have to mention about the effective collisions is higher in set 3. So it has a higher rate of reaction. Okay, question C. The presence of catalyst and the concentration of the reactants also can affect the rate of reaction between the acid and zinc granules. So choose one of these two factors and describe an experiment to show how this factor affects the rate of a reaction. So 8 marks altogether. So here you have to know that you can choose the presence of catalysts and then the concentration of reactants. You can choose any one of these factors. So here the reactants are acid and the zinc granules. Okay, so you can use any one of these factor to explain your experiments here. Okay. Okay, so first factor, we use the catalyst factor. So first we need to mention about the apparatus. So if you look into the diagrams here, so apparatus use are conical flask, delivery tube with rubber stopper, okay, burette, retort stand with clamp, stopwatch, basin and measuring cylinder. Meanwhile, for the materials we use, okay, we need zinc powder, hydrochloric acid, water, and then copper 2 sulfate solution as a catalyst. So procedure, we have to mention in details one by one. First, fill a burette with water until it is full, and then invert it into a basin of water. Then clamp the burette onto a retort stand. Record the initial burette reading. Pour 50 cubic centimeter of 0.1 mole per cubic decimeter of hydrochloric acid into a conical flask. Then put a spatula of zinc powder into the conical flask. Then immediately stopper the conical flask and start the stopwatch. Check the conical flask throughout the experiment and then record the volume of gas collected at intervals of 30 seconds for 5 minutes. After that, you need to repeat step 1 to step 8 with addition of copper 2 sulfate solution as a catalyst, especially into the step number 4, okay, together with the hydrochloric acid. Okay, for tabulation of data, so we must draw a table. Okay, set 1 and set 2, the volume of gas collected for 5 minutes at 30-second intervals. Okay, and then conclusion, the presence of catalyst in the set 2 has a higher rate of reaction than the set 1. Okay, so next, if we want to mention about the concentration factor, okay, so first, apparatus and the materials are the same. Okay, just here we no need to put in any catalyst. Okay, just now we need the copper 2 sulfate solution as a catalyst. So here the manipulated variable will be the concentration of the hydrochloric acid. So let's see the procedure. First will be the same. Fill a burette with the water until it is full and then invert it into a basin of water. Clamp the burette on a record stand. Record the initial burette reading. Then pour 50 cubic centimeter of 0.1 mole per cubic decimeter of hydrochloric acid in a conical flask. Then put a spatula of zinc powder into the conical flask. Stop the conical flask immediately and start the stopwatch. Check the conical flask throughout the experiment and then record the volume of gas collected at intervals of 30 seconds for 5 minutes. Then final steps, repeat the step 1 to 8 with 0.5 mole per cubic decimeter of hydrochloric acid, which is the higher concentration of the acid. Okay, so the tabulation of data will be the same. Okay, so set 1 and set 2. Set 2 higher concentration, set 1 lower concentration. So we record the volume of gas collected at 30 seconds intervals for 5 minutes. So as a conclusion, the higher concentration of hydrochloric acid in set 2 has a higher rate of reaction than set 1. Okay, so that is all for this video. Okay, please subscribe and like the video and then share this video with your friends. Thank you.